You know of Isaac Newton that was standing under a tree and an apple puff.
One day in autumn, Sir Isaac was lying on the grass under an apple tree and thinking. Suddenly an apple that had grown ripe on its branch fell to the ground by his side. What made that apple fall? He asked himself. It fell because its stem would no longer hold it to its branch. Was his first thought, but Sir Isaac was not satisfied with this answer. Why did it fall toward the ground? Why should it not fall some other way just as well? He asked. All heavy things fall to the ground. But why do they? Because they are heavy? That is not a good reason. For then we may ask, why is anything heavy? Why is one thing heavier than another? When he had once begun to think about this, he did not stop until he had reasoned it all out. Millions and millions of people had seen apples fall. But it was left for Sir Isaac Newton to ask why they fall.
And he thought, why this apple is descending toward the ground and not going in another part of the possibility that we have. Well, I also, observing all the units of the physics, I have seen that always all the measurement of these units are never units, but number with decimal quantity, always more little. And I ask to myself, why? Why the unit have quantity that are not units? So I thought, and finally understand. I have seen that always all the measurement of these units are never units, but number with decimal quantity, always more little. And I asked to myself, why? Why the unit have quantity that are not units? So I thought, and finally understand. When we take the measurement of everything, the first thing that we obtain is to have the unit of the measurement. Only afterward that we have the unit of the measurement, we put it as the number one, as the denominator of a ratio in which, in the numerator, there is only the remaining part. It is as we have a cake, and we decide that it is in 10 parts, and we use one part of it to take the measurement of that cake, but with a part we can only take the measurement of the remaining 9 parts. And so, in every unitary measurement, what is lacking is always the unit of the measurement, which is considered 1, also if it is not 1, and it is put in the denominator of a power in which in the numerator there is the measurement. This my consideration open a new field of investigation, as that of Newton opened a new field of investigation.
One day I stopped to look at the summary of all the constants of a physics unit, and I saw that they had all approximate numbers with decimals and to the limits of the readable. And I wondered why the units have a number other than 1. The first answer I gave was that these were from very accurate measurements, so it had to be that way. But then I thought, and thought, until I realized that at the precise moment at which something is measured in units, the first thing that is quantified is its unity, and then what remains by excluding the units, placing it as the one base of the numerator. Therefore, the measurement was always incomplete, because every time it is measured only the amount in excess of that unit, and never the total amount. In fact, if you measure a cake, considering it of 10 pieces, and you use a piece, it will be measured only in the 9 pieces equal to that.